Morning to everybody. Welcome to this ISTAT online panel webinar with two very distinguished guests. We have Kim Higgins Bergin from a senior consultant at Avitas and Mike Yeomans. Kim is a senior consultant at Avitas, where she has worked since 2017. Avitas is a full-service aviation consulting firm with senior staff that have comprehensive hands-on expertise from all facets of aviation industry, and I'm sure you're all familiar with Avitas. Another very familiar name, IBA. Mike is a director of valuation at IBA Group. Mike joined IBA in 2011. He's responsible for the valuations team. He has extensive knowledge of values and dynamics of the commercial aircraft market and has a background in aircraft maintenance and mechanical engineering. Recently, Mike has delivered a number of commercial and technical due diligence assignment appraisers in support of numerous ABS transactions and has advised new clients entering the aircraft leasing market. Furthermore, Mike conducts large portfolio appraisers on behalf of major lessors. He is often a speaker at events and writes on various topics relevant to the industry. Kim and Mike, thank you very much for your participation here in this learning lab. It's always fascinating to learn here from the appraisers on how on the market. So, Mike, the floor is yours.
Thanks very much, Maureen, and hello everyone. Pleasure to be here today. Just, if I may, share my screen and share the slides here. Okay, hopefully everyone can see the slides. So thanks once again. And myself and Kim today will be talking you through the topic of emerging sustainable technologies for commercial aircraft and aviation. This is, of course, a very prominent topic, a very important topic, and one that hopefully that you will find interesting. I'm just going to run through a quick introduction just to set the scene. So we're talking here about the net zero goal, the goal for the industry to reach net zero carbon emissions by 2050. This is a target that was agreed by all of the IATA member airlines at their 77th AGM meeting last year in October, that they would offset their carbon emissions, effectively becoming carbon neutral by 2050. So there are a number of ways that that can be achieved. If you look at the chart on the right-hand side of the screen, this is the IATA's expectations and the contributions to achieving that goal. You'll see sustainable aviation fuels is a big part of that, offsetting and also carbon capture, which we'll touch on momentarily through the presentation. But more heavily, the area we're going to focus on being ISTAT appraisers is the new aircraft technologies. And within those, there are three distinct areas that we're interested in: the hybrid aircraft, the fully electric aircraft, and the hydrogen fueled aircraft. So we're starting off really in the sort of size building from the smallest aircraft up, and we're going to focus on some of the different technologies that are being used and being developed. So with that, I'm going to pass over to Kim, who's going to talk you through the electric and hybrid electric aircraft technologies.
Thank you, Mike. Good morning, afternoon, evening, depending on where you are. Thanks for joining us. Thanks to ISTAT for having us. So when Mike and I were approached by ISTAT to participate in this Learning Lab series, we were given free rein to choose a topic covering the market in 2022 and beyond. A number of our colleagues in the appraisal program have already done a great job covering various aspects of the conventional commercial transport market earlier in the series. So in trying to think of something that was both topical and hadn't recently been discussed, skimming through trade publications, I noticed that basically every one of them had at least one article about new sustainable technology platforms, whether it was eVTOL, SAF, electric aircraft, hydrogen powered aircraft. It's just all over. So I thought this might be something of interest for the members, even if it's more in the beyond timeframe than strictly 2022. Also, as an American and something of a cynical one. I have to admit being a little bit late to the party in terms of recognizing how important and how urgent the environmental concerns are to our industry. But diving into this project was very illuminating as to the amount of effort and financing and brainpower that's being directed into some pretty innovative solutions. So while these platforms generally aren't in service today, there's quite a lot happening in the space in terms of the development, testing, certification, and the lining up of commitments. So also, while many of these aircraft are not considered to be transport category size aircraft, members of our industry are getting involved in these markets, whether it's from an airline, manufacturer, or lessor perspective. So with that being said, I do have a couple of caveats before we dig into the slides. One is that this is not an exhaustive survey of the market. In getting smarter about this sector, I've realized it could be a full-time job just to keep up with the various programs under development in the daily news, and we only have about an hour to cover a lot of ground. So if you have a favorite eVTOL platform and I didn't cover it, I'm sorry, but it's not a judgment. It's just a time limitation. So my portion today is focused on the eVTOL market and the electric aircraft market and some of the possible challenges that are ahead for these segments. Some of these challenges are going to overlap the challenges that the industry is facing overall. So final caveat, unlike Mike, I am not an aeronautical engineer, an electrical engineer, or any type of engineer. So apologies in advance if there are any technical questions that I'm not able to address. You can advance the slide, please. So again, we just sort of covered what we're going to be covering today. The eVTOL, and then I broke them into 9-seat and 19-seat categories for conventional fixed-wing aircraft, both new build and re-engine programs. And then there's some cargo and other configurations, and again, the challenges that we'll be facing. Next slide, please. For the eVTOL programs, I broke the selection down into those that were less than 4 seats and 4 seats or greater. So here's just a selection of what we're going to be talking about, some briefly, some a little bit more detail. So go to the next slide, please. So one thing that was intriguing in doing the research for this was finding out that 5 of the eVTOL manufacturers in the last 6 months have announced that they're going to be going public via special purpose acquisition company deals. So this is the listing of the 5, the date the deal was announced, as well as the implied value at the time of the announcement. I'd like to go to the next slide, please. And here's what happened. With the first 4 have begun trading. So I took the closing price on the first day of trading and the closing price Friday. And of the 4 eVTOLs that have gone public via this route, the share value has fallen pretty significantly since they opened for trading for all 4. However, none of the companies have been trading for more than a few months, and they're all still in various stages of development and certification for their platforms. So the early stock performance is not necessarily indicative of success or failure as an investment at this point. Also, unfortunately, in the case of Joby, the February 18th date was a bit unfortunate because it was the day that the crash of the prototype was announced. So the stock dove about 5%. It's actually recovered to where it was prior. Eve, we'll see what happens. Their trading should open sometime in the second quarter of 2022. Next slide, please. So in the sub 4-seat category, a few of the options include the Archer Maker, which is 2, well, they're all 2 seats actually. They did do a $1 billion deal with United Airlines and Mesa for up to 200 aircraft. Also in the news for being sued by Wisk, another one on the list here, for allegedly poaching an engineer that had supposedly had some proprietary Wisk aircraft design data. Archer has countersued, so stay tuned and see how that gets resolved. Volocopter is another one of the manufacturers, and their initial platform is the VoloCity, which is the 2-passenger version with a 35-kilometer range. They're also developing a Volo Connect, which will have 4 seats and some additional range, as well as a Volo Drone cargo aircraft. They are in the news recently because it was announced that Aviation Capital Group will finance $1 billion worth of the fleet of Volocopter aircraft once they are certified. Volocopter has also entered into joint ventures in Saudi Arabia and China for introduction of their products in those countries. We also have Whisk with their Cora platform. Whisk is a joint venture between Boeing and Kitty Hawk, which was co-founded by Larry Page of Google fame. They're interesting because they plan to certify their aircraft as fully autonomous from initial certification. They're also estimating as many as 2,000 aircraft in service during their first year of operation. However, details are a little scant regarding the specifications and performance, and the timeline for entry into service hasn't been disclosed due to the uncertainty surrounding certification of a fully autonomous platform. And we also have EHang, which is based out of China. This is a fully autonomous platform as well. The 216 name, I believe, comes from the fact that it is a 2-passenger aircraft with 16 propellers and 16 electric motors. It does have a 35-kilometer range, but requires 2 hours to recharge the batteries. So that might be a bit of a consideration. Go to the next slide, please. So in the 4-seat and up category, there are a few more entrants that we're discussing today. The first being vertical aerospace. Then we have Joby, Embraer, Airbus, Beta Technologies, and Lilium. And all of these platforms are forecast to enter service between 2024 and 2026. So while not today, the timeline is really not that far into the future. You can go to the next slide, please. So I have to admit that one of the favorite parts of my research here was finding all the images. These aircraft are beautiful and futuristic and sleek, and it's just enjoyable to see how they all differ from one another. But the vertical aerospace VX4 will have 4 passengers and a pilot. Initial version will be passenger with medevac and cargo configurations to follow. Maximum range of over 100 miles. One interesting fact is that they just announced a deal with Leonardo to co-develop the carbon fiber fuselage. And in the announcement, they disclosed that they propose a potential production rate of up to 2,000 aircraft per year. So when you look at what Boeing and Airbus are producing, this is just one of the entrants in this space. If they really produce 2,000 aircraft per year, there will just be thousands and thousands and thousands of these eVTOLs occupying the skies. So the first flight of the prototype is expected later this year with the entry into service forecast for 2024. And they have a pretty decent provisional order book, over 1,300 aircraft as of last September. Next slide, please. So the Joby S4, which has been in the news lately, has 4 passengers and a pilot. 6 propellers will tilt to transition from vertical takeoff to conventional forward flight. Maximum range of 150 miles. There are a few interesting facts about the Joby program. They're actually designing the motors and propellers and are certifying these systems concurrently with the aircraft design. They've also been working with the FAA, and they're designing the aircraft under FAA Part 23 rules for normal category airplanes with some special conditions that cover the additional capabilities to include the vertical takeoff and landing and the electric propulsion. This makes the certification more straightforward, and it's a well-defined process that allows the use of existing commercial pilots and flight within the existing air traffic control system. So it should hopefully streamline the process for them. They did just add a second flight test prototype aircraft earlier this year. Unfortunately, about a month later, the first prototype aircraft was involved in an incident and crashed. It was being piloted remotely, so there were no injuries, but there's obviously an investigation ongoing. So it's unclear at this point in time what happened or if this will affect the timeline for entry into service, which was forecast for 2024. The other interesting thing about Joby is that they're not intending for the individual aircraft to be available for sale. They're going to operate the fleet via Part 135 certificate in the US as a rideshare business. And they've also announced collaborations with ANA Holdings in Japan and SK Telecom in South Korea to offer rideshare services in those countries. You can go to the next slide, please. And the Embraer Eve, which is the most recent of the eVTOLs to announce it's going public, 4 passengers and a pilot at entry into service, 5 when fully autonomous. They have also just formalized a certification process with the Brazilian Airworthiness Authority to be certified for type certificate on the basis of normal category aircraft with some extra requirements similar to Joby. I think their thought process in this was that the Brazilians would help them certify then in other countries with reciprocity. So hopefully that smooths the way for them to get their certifications elsewhere quickly. They have what is probably the largest non-binding backlog of almost 1,800 aircraft worth 5.4 billion as of this month. And their forecast certification is 2025 with an entry into service the following year. You go to the next slide, please. So we have the Airbus, City Airbus Next Gen. This is the follow-on to the City Airbus. It's got 8 electric power propellers, fixed wing, V-shaped tail, 4 seats. Interesting, they chose to go with no moving parts or tilting surfaces during the transition from vertical takeoff to forward flight. Maximum range of 80 kilometers with the first flight of the prototype planned next year, and certification forecast around 2025 with probable entry into service in 2026. It's being developed under the Airbus Helicopters organization. Next slide, please. And here we have the Lilium jet, which is also extremely interesting. You can see it is the first eVTOL jet, and it's powered by 36 ducted fans. Has the capacity for 6 passengers plus a pilot, 7 once autonomous operations become possible. They've also announced that they'll be developing a 16-seat aircraft as their next platform. They're forecasting the batteries to require replacement 3 times a year. The list price is interesting here. It's $4 million roughly plus $1 million annual aftermarket support fee. So that's a interesting development, as is the fact that there's an expected life of 8 years. This is the only eVTOL platform where I've seen an expected lifespan put out there. So they forecast entry into service in 2024. There has been a little bit of controversy over the design range, which they list at 250 kilometers, because they were assuming a higher battery density of 320 watt hours per kilogram, whereas the currently available battery density is generally in the 250 watt hour per kilogram range. But the company says that the batteries they've selected have been bench testing at 330 watt hours per kilogram. So if that holds, then their range estimate should be good. They've had a provisional sale to Azul for 220 units. If you could go to the next slide, please. So this is the Beta Technologies Aaliyah 250C. The Beta Technologies story is really interesting to me. The company was founded about 5 years ago by a Harvard grad who was a former professional hockey player who didn't make it to the NHL. His name is Kyle Clark, and he's also the Aaliyah test pilot. Beta was his nickname in college, apparently. So we have a lot of backstory to the company here. The aircraft was initially developed for a cargo configuration, but then passenger orders were received from Blade Urban Air Mobility. So they're going to take 20 of the aircraft. UPS has a big order in with options to buy up to 150. Their first aircraft are scheduled for delivery in 2024. So it's got a vertical takeoff and landing with conventional horizontal flight with 4 top lifting rotors and 1 rear mounted pusher motor. The payload is 200 cubic feet of cargo volume with 1,400 pounds of payload, or you can take 5 passengers plus a pilot, 6 when autonomous. Maximum range of 250 nautical miles. The list price is expected to be between $4 and $5 million. In addition to the order from UPS, Amazon is also an investor in this company, as well as Fidelity Management. They also have been working extensively with the Air Force and have been awarded contracts over $43 million to test these aircraft for military applications. And another interesting piece of the Beta Technology story is that they're developing a ground charging station business as well. So they're going to set out these ground charging stations for various electric aircraft as well as ground vehicles. And the business model is based on the Tesla supercharger stations. And the charging stations will be fitted with batteries that are used and removed from Aaliyah aircraft as they degrade. And then they're going to sell new battery packs to Aaliyah customers at an estimated cost of $500,000. So they're forecast to enter service in 2024. Go to the next slide, please. And now we move up into away from the eVTOLs and into the sort of fixed wing traditional aircraft category in the smaller 9 to 18 seats. And these are some of the platforms available there, including new designs as well as some re-engine programs. You could go to the next slide, please. So first up is the Aviation Alice, and this is probably the aircraft that is closest to certification. It's currently configured for 9 passengers with cargo and a 6-passenger executive configuration also available. Maximum range is 440 nautical miles. It's powered by 2 Magni 650 engines. It's got high-speed charging with 30 minutes charge to get you an hour flight time. The first flight is scheduled pretty much any day now. I thought it would have actually taken place by now, but earlier this month, about a week ago, it was announced that the Aviation co-founder and CEO is leaving the company, which happened about a month after the departure of the executive chairman, who is also the CEO of Magniux, which is the engine maker and a sister company to Aviation. So it's unclear at this point if the departures in the executive suite will impact the timing for the remaining flight test program or entry into service, which is currently forecast for 2024. The known customers include DHL, which is taking 12 in cargo configuration, and Cape Air. You can go to the next slide, please. The Airflow M200, another interesting platform because it's available with amphibian or fixed gear options. It's effectively a utility aircraft designed to replace the Cessna Caravan or compete with the Cessna Caravan. 9 passengers or 2,000 pounds of payload, max range of 500 nautical miles. This one is hybrid electric, so there's a turbo generator that powers the distributed electric propulsion. This is just an artist rendering, so it's unclear at this time whether those are actually going to be 10 propellers or 8, but it's going to be a similar setup regardless of the number. The list price is $2.75 million, and it's forecast to enter service in 2025. They have a $600 million order book reported, which includes orders from Raven, Alaska, and Tailwind, which is taking the aircraft in amphibious configuration. Next slide, please. Another really interesting platform, the Regent Viceroy. So Regent isn't a company name, it's an acronym, which stands for Regional Electric Ground Effect Nautical Transport. This is not an aircraft, this is a sea glider that operates in wing and ground effect. The first variant is going to be the Viceroy, which will carry 12 passengers, but they have announced that the next version will be the Monarch, and that will take up to 50 passengers. There's a maximum range of 180 miles. The process is it will motor away from the dock on hydrofoil, take low speed takeoff over water, and then the cruise will be up to 180 miles per hour. This will not initially be certified by the FAA. It's going to enter service under Coast Guard authorization, and it's forecast to enter service in 2025. I believe the flight test will be later this year in Tampa Bay. And Mesa recently announced plans to invest in the company as well as order 200 of the sea gliders. Next slide, please. The Technum P-Volt. This is an electric powered version of the Technum P-2012 Traveler platform. Can carry 9 passengers, also available for cargo, medevac, or special mission configurations. The Traveler was certified a few years ago, and 37 have been produced, 30 of which are with Cape Air, either in service or in storage. The maximum range might be a bit of an issue on this. It's 85 nautical miles, so that's going to significantly limit the number of routes that can be flown with this. The power plant is 2 Rolls-Royce 320 kilowatt electric engines. Unclear on the timeline for forecast entry into service, but customers include Cape Air and Widerøe. Next slide, please. The Cessna Grand Caravan EX Hybrid Electric. This is a re-engine program with Ampere. They're going to do an STC with the Ampere EP1 power plant. The hybrid aircraft is forecast to save up to 50% in fuel and emissions, as well as 25% in direct operating costs, with no loss in range and performance. So that's quite a contrast to the Technum P-Volt. The hybrid doesn't require charging infrastructure. It can charge in flight similar to a Prius automobile. So you use the engine to charge the batteries while you're flying. And the upgrade is expected to cost less than the combustion turboprop engine it's replacing. The entry into service is forecast for 2024. And interestingly, Surf Air Mobility, which has a sort of charter membership program, has announced a year ago they were going to be purchasing Ampere, the engine manufacturer, and that hasn't closed yet, but it's still in process pending financing. They've also announced orders for Grand Caravan aircraft, 100 firm orders and 50 options, and they're going to take these aircraft into their fleet, and once the STC is available, they're going to re-engine them with the Ampere power plant. Textron's actually supporting them in the STC process, and they will also support them with sales and marketing outside the US once the certification is achieved. Next slide, please. So here we have the 19 seat and up category, and as you can see, the offerings get slim because the battery technology doesn't really support the performance needed to carry more passengers, but there are a couple of entrants in here. You can go to the next slide, please. The Heart ES19, which is a 19 passenger platform. That picture is of a subscale prototype. Maximum range of 400 nautical miles. It does have high-speed charging, so 40 minutes to charge for the average mission. The battery life expectation ranges from 1,000 cycles, most likely, but may increase up to 3,000 cycles. Interestingly, they say the battery is expected to be approximately 2% of the total aircraft price. So that's either a pretty inexpensive battery or a fairly expensive aircraft, but we don't have a list price for them, so it's hard to determine at the moment. The forecast entry into service is fourth quarter 2026. So this one's a bit farther away, and customers already include United Airlines and Mesa. If you could forward to the next slide, please. Then we have the Faraday BHA M1H. So this is a hybrid electric aircraft, has multiple uses. There's a 19 passenger configuration. It can convert to cargo in 15 minutes under the QC configuration. There's firefighting, regular just passenger. The cargo capacity is 3 LD3 containers, 450 cubic feet of payload up to 5 tons with a maximum range of 1,100 nautical miles. 2 Magni 650 engines are the power plants. The target list price for a base spec aircraft is $6.3 million, but the initial portfolio of 300 aircraft is going to be owned by Faraday and I guess leased out to operators. They're saying it'll be 150 firefighting aircraft along with 75 in QC configuration, 25 in cargo, and 25 in other. So I'm not sure if there's already some deal in place for the firefighting aircraft because that seems to be a fairly high percentage of a new fleet to go to firefighting, but I guess time will tell. Forecast entry into service in the 2026-27 timeline. Go to the next slide, please. And finally, we have the Eco Otter SX, which is a NASA project in conjunction with Ampere, which is providing the engine technology to re-engine the Twin Otter aircraft. The idea is to see if this electric engine capabilities can be scaled to serve larger platforms. So it's unclear if this will be offered on a commercial basis, but it is out there and interesting, and the Twin Otter fleet just seems to keep going and going. So if it's available, there may be some good uses for it. Next slide, please. This is just a listing of some of the other configurations along with cargo configurations for these platforms. So they do go from eVTOL all the way up to the larger electric powered aircraft. There's firefighting, which is the EHOM 216, which is interesting. A lot of cargo and medevac, executive. The float plane is interesting to me. It's fixed gear or float plane, so it's also utility, cargo, or passenger aircraft. Next slide, please. So what are some of the challenges ahead? Batteries, the cost, the infrastructure, air traffic management, pilot shortage, all of these things are facing the electric aircraft market, and some of them are also facing the conventional aircraft market. Go to the next slide, please. So the batteries is a big thing. The battery density is currently the main limitation on performance for these aircraft. Most of the platforms are using existing automotive battery technology, which, as I mentioned, is about 250 watt hours per kilogram. But there's actually been a recent development where a new lithium air battery is being developed by Japan's National Institute for Materials Sciences, and they're claiming 500 watt hours per kilogram with charging and discharging at normal temperatures. So if this performance holds on the battery, this could actually be a big step forward for the electric aircraft market because it's going to double your capacity. So while most of the platforms are using the existing technology and have just a proprietary arrangement of how the batteries are put together and contained, Faradair is actually working with a partner to develop a custom aviation battery solution. So they're doing something a little bit different. But as the battery performance and price improve, so do the prospects for electric aircraft. It's similar to computing power. You know, there's not the same ratio necessarily, but the prices are coming down and the performance is improving. So right now, for most of these platforms, a charging station would be required. Generally, they can use dual purpose aircraft ground equipment chargers, but some of the platforms have their own specific chargers. Hart has estimated the average cost of an ES19 charger to be $500,000. Batteries are forecast to have to be replaced generally annually for commercial operators. The used batteries might have a second life in non-airborne uses. They can be used to charge ground equipment and other places where it's not as critical from a safety standpoint to have that full battery load. And ultimately, about 50% of the battery materials can be recycled. Next slide, please. So performance. The payload and range are reduced when you switch to electric power on a conventional platform. The conventional aircraft configuration isn't really optimized for battery packages. The outlier here so far appears to be the Cessna Grand Caravan because there's no loss in range, but it's actually a hybrid electric. It's not a fully electric aircraft. When you look at a fully electric aircraft like the Technum P-Volt versus the P-2012, there's an incredibly significant loss of performance on the range. If you see the P-2012 Traveler is 950 nautical mile range, and you get reduced to 85 nautical miles with today's technology. Now they're projecting in 2030 that will increase to 145 nautical miles. So it's still such a huge performance hit when you go to electric on a design that is not clean sheet. Next slide, please. So infrastructure is an issue. Many of the electric programs need commercial charging equipment that's not specific to their platform, so that's encouraging, but there will still be some airport adaptations required for the conventional fixed wing aircraft. It's unclear who will pay for these at this point, if it will be the operator, the airport, or some combination. eVTOLs are a whole different story. They're going to require vertiports. They can probably use existing helipads to begin with, but there's going to be such a huge volume of eVTOLs that they're going to need more landing sites. So some are looking at rooftops as an option, but others will be new sites that will have to be built and presumably certified in some manner. And next slide, please. Air traffic management. This is another issue that will be generated by the massive increase in vehicles in the skies, but could affect all of the participants. So the Bureau of Labor Statistics forecasts only a 4% growth in air traffic controllers over the next 10-year period. Who is going to manage all of these aircraft flying around? The good news is the eVTOLs, because they have such limited range and short route profile, won't need to fly very high, but they're still going to be in the sky. So NASA and the FAA are working on all kinds of programs together. NASA has this air traffic management exploration program, and they're trying to develop new solutions with digitally integrated air traffic system to accommodate all of the users. Advances in cloud computing and automated systems are going to be needed. There aren't going to be enough people to just manage this. You're going to have to automate at least a part of the process. Next slide, please. Also, pilot shortage. So I pulled some statistics from the US, the active airman certificates at year end. And over the past decade, this was surprising to me, the commercial and ATP combined pilot numbers only increased by 5,000. So you have these electric technology aircraft, and particularly with the eVTOLs, they're going to bring lots and lots of aircraft with relatively low passenger counts. So the BLS forecast 13% growth in airline commercial pilots for the next 10 years, but in early 2021, Oliver Wyman forecast a pilot shortage of 35,000 to 50,000 by 2025. So the one thing that really strikes me about this chart is that, and I apologize, it's not incredibly easy to read, but the red line is airline transport pilots, the yellow is commercial. So you figure the airline transport pilots, if you need more of those, you're going to pull them from the commercial group. Rotorcraft pilots are very limited. They've actually decreased by a couple thousand over the 10-year period. But the orange line, that's remote pilots. It wasn't a certification before 2016, but it has gone from 0 to roughly the same amount as air transport pilots and commercial pilots combined in a 5-year time period. So that's going to be a big part of your answer, I think. Next slide, please. So the pilot shortage. Vertical Aerospace proposes a build rate of 2,000 aircraft per year, one platform. Who's going to fly them? Initially, at least, most of these platforms are going to be piloted. So some operators are taking matters in their own hands. Joby and United are both developing pilot training programs. So Joby has started ground school for its employees with the idea of transitioning into flight school for its employees first, and then for Joby pilots. United has established a pilot training academy in Arizona, and they expect to train 500 pilots per year. They just ordered 25 Cirrus trainers with options for more. Another thing that we can do is lobby for change in the regulations. Mesa Airlines CEO has been in the press lately arguing that the 1,500-hour rule needs to be reduced because it's causing problems in getting the air transport pilots certified. Very innovative solution is to go with the Regent Sea Glider. They actually require boat captains instead of pilots. So that's one solution, albeit a very small one. But essentially, autonomous aircraft are going to have to be a large part of the solution. So these platforms, almost all of them initially plan to certify with pilots, but they all generally admit that the economics really begin to work once you remove the pilot and you have that extra passenger seat available. So the question is, will this open the door to single pilot or autonomous operations of larger commercial aircraft one day? Not today, probably not tomorrow, but maybe one day. Next slide. Oh, I'm done. Back to you, Mike.
Thanks very much, Kim.
Thank you.
Really interesting to see how many different aircraft models and types that there are in development, and the different technologies that are being used there. So see how the skies could be quite congested if all of those are delivered in the numbers that you said there. So I think in the next few slides, I'm going to talk through some of the potential technologies that they could be applied for the largest of commercial aircraft market. So I'll start off by looking at some of the OEMs and how they are investing in decarbonization and what sort of strategies they're taking to achieve these net zero targets, which are faced and committed to by the airlines. So there are some different concepts and different approaches to this. Airbus is really going all in on the hydrogen technologies with its zero emissions concepts. So currently there are 3 aircraft proposed, which we'll dig into in a little bit more detail in a few slides time, which are expected to enter service around 2035. Boeing's taking a little bit of a different strategy. They're less convinced on the hydrogen technology and placing more emphasis and more investment into the sustainable fuel side of things at the moment, although they are invested in the urban air mobility, which is what Kim was mentioning earlier in the presentation, which that side of the market is highly competitive, as well as we saw in the number of different aircraft types that will be entering service over the coming years. Embraer, as of late last year, launched their Energia concept. So there's a 4 aircraft family of aircraft which cover various different technologies, looking at fully electric, hybrid electric, hydrogen, using both fuel cells and a gas turbine. So some very interesting technologies being used there, and those should enter service between really 2030 and 2040 across those different aircraft types and technologies. So the technology is clearly one way that we're going to achieve the target, but as you saw from the earlier slide, the IATA slide, sustainable aviation fuels are going to be a very much a near-term solution to becoming carbon neutral for the large aircraft market. So These are fuels that can be burnt in the same way as Jet A1 and fossil fuels, but they come from a variety of sources: plants, plant oils, cooking oils, various forms of waste, rapidly grown plants and algae. And they're becoming more and more common. We saw BA operating its first sustainable aviation fuel flight last year in 2021. IAG is committed to powering 10% of its flights by 2030 using sustainable aviation fuels. And within Europe, there is a significant commitment from the sort of political governmental level to using SAF. So there's a mandate that's going to start in 2025 that 2% of all flights that depart EU countries will be required to have 2% SAF content. And that's going to increase over the coming years in 5-year increments, such that by 2050, 63% will be SAF within the aircraft powered by 63% SAF. So some significant targets there. There's also some legislation going in there to prevent airlines from fueling outside of Europe, tankering in, and then flying back out with the fuel that's already on board. So that will not be an avenue to sort of bypass that legislation. So this is clearly going to be a big part, particularly in Europe. Perhaps other regions will follow suit on that basis. So the OEMs committing to this as well in the operation of their aircraft and in the delivery of their aircraft. Airbus have started using SAF blends to deliver aircraft from Mobile and Hamburg. Boeing's invested in a blend of SAF, which is going to power test flights, delivery flights, as well as powering the Dreamlifter fleet. So we will see this increasing. We'll see the number of operators using SAF increasing over the coming years. Currently, the regulations only allow for a 50-50 blend, but it's hoped and planned by 2030 that we'll see 100% SAF allowed. I think that's by 2025, 2030, we'll probably see that. So is it an immediate option for all? Well, production facilities at the moment are limited in terms of the capacity. The cost around 4 times higher than conventional fossil fuels, so not so much of an option for all on that basis. The IATA forecast is that by 2035, around production will allow for 17.5% of all global aviation fuel to be sustainable. Now, there is some controversy, some concerns around sustainable aviation fuel and how sustainable really is it. One of those arguments is the land use. So it does require for some of the types of sustainable aviation fuel to set aside large volumes of lands to grow the crops that you then turn into fuel. Could that be used for an alternative use? Could it be used for growing food? Could whatever you're growing on that land be sequestering CO2 from the environment anyway that you may then not burn in the engine of an aircraft? So there are some questions around it. But when we look at the technology that's available today and that's going to be available over the coming years, it still has to be an important part of the solution to getting to these ambitious net zero targets that the industry has set itself. So how are the airlines going to address these targets? Well, sustainable fuels, just mentioned, that's going to be a key part of it, and certainly in the next 5 years, but that will continue over the next 20 years realistically, and the use will increase. We already have technologies in place, aircraft like the Boeing 787 using the more electric principle, using less bleed air systems, using more electrical systems on the aircraft to reduce fuel burn effectively. So there are already some technologies in place that look at that. Improving the air traffic management and the flight profiles. So we're avoiding contrail formation, more direct routing, less time holding to go into airport, which has been less of a problem over the recent years, but was certainly a big issue at some of the busier airports pre-pandemic. So making better use and advancing those systems. There's the research that's done by Airbus around the fellow fly, so flying like geese in formation to make use of the trail behind the aircraft in front to improve efficiency. whether that will take off, we'll see. Carbon offsets are going to be a key part of this. That's going to go right the way through the 20-year forecast. But then once we get 5-10 years into the future, we expect to see more, as Kim has mentioned, some of those smaller hybrid electric regional aircraft, a fully electric regional aircraft. We'll see the sustainable fuel network and the supply of sustainable fuels growing. We'll also expect to see carbon capture. So that's where CO2 that's already been emitted into the atmosphere is then captured back from the atmosphere. There are a variety of things you can do with that. You can pump it into the ground. You can sell it for commercial applications. You can actually turn it into fuels, which you can then burn again. So it's sort of making it a bit more of a cyclical use, taking the CO2 out of the atmosphere and then putting it back in again. At least it's not creating more. And then in the longer term, particularly for the large aircraft applications, we'll see hydrogen. We'll see development of networks to supply and to generate hydrogen, and we'll continue to see the use of the sustainable fuels and the carbon offsets. Just to take a little look at each of the technologies, we've gone through some there on Kim's slides. So hybrid, is it a niche? Is it going to be suitable for applications in large aircraft? Well, when compared to electric, compared to the hydrogen, sustainable fuels, it does look like it's going to be more of a niche application. Currently, we've seen most of the power plants, most of the technologies being employed in the smaller aircraft, the largest of those being up to really the 19-seater. We did see Airbus sort of pursuing with its EFAN and EFAN-X programs, the hybrid in development with Rolls-Royce. It's since left that by the wayside and moved more towards the hydrogen applications. So in terms of a broader use in the large aircraft, commercial aircraft market, don't really expect to see hybrid technology playing a big part. On the right-hand side of the screen, you can see we've listed a few of the aircraft that are employing these technologies. Kim's gone through some of those already, so I won't go through those in great detail, but one of the Energia models, the 9-seat E9HE, will be hybrid powered using piston and electric motors. The Technam, Rolls-Royce Rotax Technam aircraft, initially using a hybrid and then moving into the P-Volt as the fully electric version. Also Cessna looking at that, and Ampere, as Kim's mentioned. So won't hang on those too much, as hybrid is not going to be so much the focus for the large aircraft market. But will the electric? I think in the fully electric market, we will probably see that confined to the regional and the smaller regional still. As Kim's already put to you, the battery technology and the energy density is really an issue once you try and get aircraft up to a significant range. Jet fuel 50 times more energy dense than batteries. So if you want sufficient range, you need a lot of batteries which are heavy. So that is, of course, a limiting factor. So for the established OEMs, larger aircraft, Airbus, ATR, they seem to be favoring hydrogen technology as a means of making their aircraft carbon neutral. So it's more likely that we'll see this in the smaller sub-20-seat aircraft market. We're seeing, though, that there is a market and there are startups going into this space. We've seen Ampere, Aviation, Hart going all into that sort of sub-20-seat market. And there's a plethora of new power source OEMs as well, including Electrifly, Magnex, and Wright Electric, who are also developing aircraft as well. So in terms of the application, it's going to be much more suited towards the smaller aircraft. So what is going to be the solution for the larger aircraft? Well, it seems that that is going to be, as well as near-term sustainable aviation fuels, hydrogen is going to be the way forward. And universal hydrogen, Zero Avia seem to be leading the way in terms of this development. So there are testing on some of the larger turboprop types, ATR, de Havilland Dash 8. There's going to be options from both of these OEMs, let's say, to retrofit aircraft with hydrogen fuel modules. So there's two ways that you can use the hydrogen. You can either use it in a fuel cell, where you're using that to generate electricity that then powers motors to power the aircraft, or you can burn it in a gas turbine. So these initial hydrogen hybrids, let's say, that will be powering the turboprop aircraft are likely to be the more the fuel cell kind of applications. We've seen orders already placed for Universal Hydrogen and Zero Avia for ATRs, Air Nostrum ATR as well, some of the orders that have been listed there. So is it the silver bullet? You mentioned that it's probably the most suitable of these technologies for larger aircraft, but there are certainly some development issues and drawbacks. So it's not yet a mature technology. The concepts, particularly from Embraer and Airbus, are not set to enter service at least into the mid to late 2030s. With new programs, technological developments, that can certainly push to the right. Another issue, additionally to electric aircraft, is the costs and the infrastructure that is going to be required. Now, the issues around hydrogen, it's got a very good energy sort of density for its weight, but in terms of its volume, you require 4 times the volume that you do of jet fuel to get the same amount of energy. So within the aeroplane, you need a lot more space for the tanks. And the tanks also need to keep the hydrogen in liquid form, and hydrogen is a liquid below minus 253 degrees Celsius. So that in and of itself is clearly a challenge. So even once you've got the fuel into the aeroplane, and if you manage to keep it at that low temperature, the cost of producing, building, refueling facilities, the supply networks that are going to be required to transport the liquid hydrogen to the airport to refuel the aircraft is going to be significant. So that may limit where the aircraft are able to be operated from initially. And of course, the hydrogen, the liquid hydrogen, has to be produced in a sustainable way. So there's going to be energy requirements and electricity requirements in order to generate that hydrogen to put into the airplane. So it is a long way to go before this technology is widespread and used across much of the large commercial aviation fleet. But looking at the timelines, by 2024, 2025, we should see some hydrogen-powered aircraft in operation, even if it is in the sort of smaller capacity in the large turboprop market. I've chosen on the next couple of slides to focus on a couple of the programs that are looking at hydrogen. The Airbus Zero E, as I said, Airbus has really gone all in on the hydrogen. So at present, there's 3 models that they're developing, which should be in service by around 2035. There's perhaps a potential for that to slip, but they do seem very committed to that target. There'll be a turboprop model, which will be likely up to 100 seats with a range of up to 1,000 nautical miles. There will be, that's on the nearest picture that you can see on the right-hand side there. There'll be a hydrogen hybrid turbofan, more of a conventional sort of bodied fuselage design with up to 200 seats and a 2,000 nautical mile range. So very much sort of in the ilk of the A320 family, but hydrogen powered. You can see that aircraft being very successful if it comes into the market and is successfully developed. And then there's perhaps a more futuristic looking hybrid turbofan blended wing, which would have up to 200 seats and a 2,000 nautical mile range. And that perhaps gives some options, alternative options for storing the fuel, which is very important given the fact that you need a lot of space, given that low sort of energy volume that you see there. Given that storage is such an important part of this, Airbus is really investing heavily in this technology. It's built some zero emissions development centers in Germany and in France, and that's in the near term really to address some of those key challenges around storing the fuel. So they're developing cryo tanks, which are likely to go into ground testing by 2023. And then by 2025, those should be ready for flight testing with that goal of bringing the aircraft into service in the mid-2030s. We know that today, actually, Airbus has, in somewhat breaking news within the last hour or so, signed an agreement with CFM for a direct combustion engine, and it's going to use the A380 as a flying test bed, which will have 4 liquid hydrogen tanks mounted at the rear of the fuselage to move towards this goal of entry into service of the technology by 2035. So they are clearly partnering and putting a lot of investment into this goal of getting the aircraft into service. When we look at what Embraer is doing, they have a 4 aircraft family that they're bringing into service, the Energia range. I've focused really on just 2 of the models, the larger models. So this one's a 19-seat hydrogen electric fuel cell powered aircraft. So that will have a range of 200 nautical miles. It's a somewhat shorter range on that aircraft, and a 19-seat capacity. It'll have 0 CO2 emissions and will enter service in 2035. Still one of the smaller, sort of still in that 19-seat territory, but this aircraft, the larger of the Energia family, the E50 H2 GT, which I'm presuming to mean gas turbine, as that will be running hydrogen through the gas turbine. That will have a much longer range of 500 nautical miles, which for a turboprop aircraft, that should serve well, as they're commonly used on up to 400 nautical mile routes. So that should serve a lot of the routes that you would look to operate with a turboprop aircraft of that capacity. Again, 100% CO2 reduction, burning the hydrogen through a gas turbine. Your emission is water vapor there. So very efficient aircraft if that's developed, very environmentally friendly and a reasonable capacity, potentially entering service in 2040. And just on the last sort of couple of slides, I wanted to look back at how long it has taken for aircraft programs to be developed, to be launched and to enter into service. I've kind of chosen the narrow body segment really as this is where I look to get to in the nearer term with some of these technologies. And we're focused on the Boeing 737 product and the Airbus A320 family product. And there's a few key themes that you can see through here. Since the 1960s, typically the launch cycle, as in from the launch of one program or one model to the launch of the next, has been around 15 years. That's very much true for the 737, slightly offset for the A320. You can see the initial launch in 84. You then saw an entry into service in 88. Some of the new engine technologies, the A5 V2500 engine and the 5B in the sort of mid-90s. You can see it for the Boeing as well. So it launched initially in 64, the Classic in 79, the NG in 93. So it's very much been in that sort of 15-year, broadly speaking, period. And subsequently from the launch, we've seen between 4 and 6 years for that aircraft to come into service. But one very important theme is that most of these new models have been an iteration, an adaptation, an improvement, and an evolution of the previous version. This is not what we're looking at in terms of the future with these new technologies. We're looking at very different technologies and a real paradigm shift in that propulsion technology for 100+ seat commercial aircraft. So we can see that the time between the launch and the time when the aircraft is likely to enter service, given the certification, the research and development, is likely to be much longer. So looking forward over the next 20 to 30 years, we know that that timeline is going to be extended. These technologies are not mature, and particularly for hydrogen, there's going to be that very strong infrastructure requirement. So just give a timeline from 2020, really. We've seen some of these concepts launched, the Zero-E, Embraer launched the Energia concepts, and we should see some of the ground testing for the hydrogen technologies over the next 3 to 5 years. So that will set the way for further developments. The Zero Avia High Flyer 2 aircraft, which are developments of the conversions, of the Dornier 228 to be used as research and development for some of that clean hydrogen powered flight. So that will be relatively soon. We're seeing Pratt & Whitney Canada developing hybrid technologies to power some of the Dash 8 aircraft, hydrogen technologies in 2024. We'll see 24, 25, Zero Avia, as I mentioned before, and universal hydrogen powering some of those larger turboprop aircraft. So we will see more hydrogen power, at least in this decade. More so, I would say, in the next decade, where we'll see aircraft like the Wright Aviation, Wright 1. We may see that as a single aisle aircraft, 186 seats coming into the market. That would be, very key if that aircraft comes into market at that point. Zero Avia, perhaps with single aisle aircraft coming in the 2030s. We'll definitely see sustainable fuels being a key part of this in the 2030s, and we expect both Airbus and Boeing and Airbus products, being 100% SAF compatible by 2030. And then in the mid 2030s, that's where we're really expecting to see these larger aircraft programs coming into the fore. The Zero E from Airbus expected 2035, the Embraer E50 GT aircraft by 2040. And these are all, I would caveat, these are all the published sort of target entry into service dates from those relative manufacturers. There is a good chance, given the time and the requirement that there is to develop these and certify these technologies, that could slip to the right. So we see the arrow to 2040, 2045. That's more an IBA view on when we're likely to see a new single aisle product, potentially hydrogen powered, from Airbus and Boeing. So we're still a long way off, but there's a lot of exciting developments to watch in the meantime. So just on the last couple of slides, perhaps be remiss not to touch on aircraft values being appraisers and what might be the impact of these new technologies on existing aircraft that are in operation today. Well, from a narrow body and wide body product perspective, the impact is likely to be limited. And we're not going to see these aircraft technologies that can replace these aircraft for, I would say, at least 20 years. Some of the near-term technologies in terms of sustainable aviation fuels are going to be compatible with those technologies, so they will be able to be operated using those fuels. So that 20 years timeline is longer than what we would typically have seen historically in terms of the replacement cycle. So that will feed into and support the value projections, at least IBA's value projections from a base value perspective. These are pioneering technologies. So as I've mentioned a couple of times, there is an inevitable delay, I would say, in terms of certifying and bringing those aircraft into market. We've even seen delays on existing technology, conventional jet-powered turbofan aircraft. So from those perspectives, IBA certainly don't see a risk for the existing generation aircraft, which are going to be the mainstay for the foreseeable future. Where we may see some potential nearer term disruption is perhaps in that smaller turboprop market, perhaps certainly under the 19 seats. And if Kim has any points you want to make against those on the existing technologies, she'd like to make some points on this next slide though, so I'll hand over to Kim.
Sure. Thanks, Mike. The new programs and the new technology may become challenging to value initially, because as appraisers, we prefer to use the comparables approach when data exists. We like to look at what the recent sales transactions or lease transactions are. And with these aircraft, we won't have that. And we're going to have to look at other approaches, including the replacement cost approach or the income approach, potentially, depending on what the situation is. Some of these platforms aren't even going to be made available for commercial sale. So if they're trying to get financing, we'd have to look at what that value is to the aircraft to them in something like the case of a Joby. So some of the considerations could include what are the cost savings versus your conventional alternative? sometimes you're not really replacing a conventional alternative from an aircraft perspective. With these eVTOLs in particular, it's a replacement of a mix of ground transportation and helicopter usage and just stimulating a new market. So the conventional alternatives may not exist in the like for like category. So you could look at the value and use, and you also might have tax credits or government incentives for some of these programs as well, because a new technology may require some assistance to get acceptance in the market. So it's really just not going to be as simple as prior valuation exercises.
Thank
Oh,
you.
so,
I think,
I'm sorry.
Do you want to take this
so-
one?
I'll take the first part. So as I mentioned, the eVTOLs are going to be replacing a variety of transport options. So they're largely designed to take care of car service, but there's also going to be some helicopter missions that are flown by eVTOLs, particularly things like organ transport, and some of the ones with a little bit longer range will be used for sightseeing flights or inter-island transportation, that type of thing. And I'll just go ahead and slip down another bullet, which is the hybrid and the fully electric technologies. They really are only suited for smaller applications at the moment. Now, as we've mentioned, as the battery density improves and the price comes down, that could change. And it could even change for some of these programs that are coming up in the next couple of years. The battery development, if you can get twice as much energy density out of the battery, that's great news. And maybe that will be able to be incorporated, but this isn't going to replace a 737 and certainly not going to replace a wide body. And I'll turn the rest over to you.
Thanks, Kim. No, I think from that perspective, from the narrow body, wide body, large aircraft, near term, it's really going to be the sustainable aviation fuels that contribute to reducing CO2 for the operators and for the airlines to meet those targets. And then longer term, maybe we can see some improvements in battery technology, but given where some of those large OEMs are focusing, it's definitely going to shift more towards use of hydrogen technologies, either be that in the form of fuel cells and or gas turbines. So that we're still a long way away from that, as we identified. It's probably 20 plus years away. So there's no cause for concern if you're operating a A320neo or 737 MAX for a while yet. So I think that is the last slide that we had in the deck. So we have time for questions.
Well, thank you both, Mike and Kim, for this. I mean, really taking on the most challenging, item for that affects all our industry for the long term. So, I mean, that was a very comprehensive overview of the current solution and challenges for concerning this, this technology. So. For me, you covered the main challenges I see that really on the eVTOL. There's so many programs. Some of them will definitely gain traction and success, but they have challenges as far as the pilots and ATC. But the more fundamental and really for most I think of the audience is what's going to happen with the narrow bodies and wide bodies, and there really is SAF and hydrogen, and both will require massive investments over the coming years. And hopefully there will be some technological breakthrough that will make them more practical in application. So we do have a few questions, and Richard they reminded us, and Mike, you picked up on this on the breaking story we had earlier today between Airbus and CFM. So good one, Mike. Richard also asked, aren't the eVTOL really helicopter-like types? And I think Kim, you made the point that the impact on commercial aviation market is kind of limited. He's saying at best they are a way to get to and from an airport from a downtown location. Anyone want to comment on this?
Sure, I'll comment. I don't think he's wrong, but the reason we included them is that so many of our industry participants are getting involved in this segment. You have airlines ordering hundreds of these, you have manufacturers developing the programs, and you have lessors getting involved. So it's not really our traditional market in terms of size, but it's pulling in the participants from our market. And so we just need to be aware that it's coming, and it is something that the airlines and the manufacturers and lessors and financiers are all getting involved with.
Yeah, thank you. Oh,
Yeah, go on.
I know. I just going to add. I completely agree. I think that there maybe some of the airlines are looking at integrating that, as a feeder network into their, existing larger aircraft operations. I absolutely see it as a replacement, maybe longer term, for some of the helicopters accessing, urban areas, but perhaps there'd be offshore users as well for the aircraft once they have more developed range capabilities. That could be for some of the further field offshore applications as well. But yeah, they're not going to be replacing, as Kim was saying, 737 to A320s due to the size, capacity, range.
Thank you both. Jen, do you have any questions, or you want to add anything to the panelists?
I don't have any sort of question related to that one. I think we have a couple more questions from the audience. Raymond asked, are there any airline MROs interested in the eVTOL programs? Would they be assisting with the development and or maintenance, or creating like joint ventures with the manufacturers?
So I can't answer that conclusively, but in all of my research, I did not find any evidence of that yet. It may just be too soon, because these aircraft, I mean, even all of the specifications for performance, they're all still certifying. So the figures may change, the maintenance program may change. It's a very new set of circumstances that the certification is dealing with in most of these instances, Joby being an exception, and possibly Eve, where they're certifying under normal aircraft categories. So I think the answer is that it's probably just too soon, but keep your eye on the space.
Okay, and I think Richard has also had a subsequent question. I think this is to you, Kim. Are the quoted ranges the same for normal aircraft, i.e. allowing reserves and diversions and absolute ranges, or is it, I mean, I'm not sure if you're able, if you, from the research you've done, you're able to answer this question. Probably.
Yes, generally those are, all of the ranges quoted were assuming traditional reserves and current sort of regulatory requirements. If it was noted, if it wasn't noted, I assumed it was, because I didn't have any information to the contrary. Yeah. But again, a lot of these data points may change because they're not certified yet and they're still in development in some cases. And again, with the battery density issues and this new development out of Japan with the lithium air batteries, I don't know if these are too far down the track to incorporate that yet, or if it will be a second iteration, but there may be further changes coming as the technology improves. Well, there definitely will be. It's just a question of whether that will be prior to entry into service or not.
Well, if there's no more questions, you know, this subject matter will continue to evolve, and there will be consistent changes and new players coming in. And as I said, it will continue to affect our industry for the long term. This is the one major, you know, challenge to our industry, and it's I'm sure there will be many more players getting involved and hopefully pushing us towards, you know, long-term sustainable air travel. So thank you very much, both Kim and Mike, for the very you know, complete presentation of the current solution, and thank you the audience for participating with your questions, and look forward to seeing you next time.
Thanks very much.
Thank you.
everyone.
Thank you.